thanks everyone for coming to the panel, and thanks to the panelists for agreeing to be on the panel. So we are going to go around do a small introduction.
I'm Alfredo Grieco. I'm a professor in telecommunication at Politecnico di Bari, Italy. And currently I'm chief editor of a couple of wireless journals, Transactions on Emerging Telecommunication Technologies and Internet Technology Letters. And I'm studying information-centric networking since at least 5 years, but perhaps even more. And I think this is a very nice field to investigate, but its potential perhaps requires our efforts in order to be really disclosed. So more to come.
Hi everyone, my name is Teng. I'm a third-year PhD student in University of Arizona. I'm currently working with Bechuan. So currently my research interest is in how to Indianize existing IP applications so they can communicate with each other directly. Yeah.
Okay, my name is Afanasyev. I'm right now assistant professor in the Florida International University, and I'm working a lot on NDN, named data networking, in various places.
Lixia Zhang, professor at UCLA. I think everyone should just talk about what's unique about you, right? So I think the unique thing about me is that I jumped into doing IP networking back in 1981. So therefore, I know lots of history, and I saw how IP got rolled out. That showed us the example how we may roll out NDN in the near future.
My name is Toru, Hasegawa, professor at Osaka University. So I studied ICN for 5 years. Then so currently, my project focus on the high performance NDN further and the privacy issues in naming. Also, some kind of the location-based findings for the ICN. That's it. Thank you.
So thanks. So I should have mentioned the panel is about how we deploy ICN in real world for real world applications. So before we go, so I wanted to know where we are right now. So in terms of maturity of ICN, where do you stand? Not so much time-wise, but protocol-wise or software development. So in your opinion, where do you think we stand?
Yeah, I believe that there are plenty of exemplary demonstration of the utility of ICN, and it's a very useful approach. Problem is that perhaps they are too much scattered. So each group tends to investigate its own view of ICN or NDN, and perhaps we should try to focus a little bit in order to work more as a community on that topic. Otherwise, it will be difficult in a few years to build a clear and unifying view, and to make our efforts something that aim at the same target. Now there are a lot of initiatives, but it is not clear where is the focus of these initiatives. And so this perhaps it's a natural part of research, but since ICN concepts are as far as 10 years ago at least, I think it's time that the community starts focusing on some concrete objectives that should be stated, declared, and actually met by ourselves. These are my two cents on the topic.
Lisa.
I thought we go by sequence. No,
it doesn't have to be.
I'm just writing down my answers.
Okay. So Teng,
Okay.
do you want to go?
Okay. So, as a student, also an NDN developer, the NFT developer and application developer, my current understanding is we have NFT, the daemon, the following daemon, and it's very robust actually. People do research on it. People implement whatever they want in the NDN in NFT. So we have NDN testbed. So normally we also have NDN SAM. Normally people do research in the NDN SAM first, and when they verify their ideas, they put their ideas to implement that in NFT. So the next step, they can deploy it in real testbed to test if it works. I'm thinking the best place to deploy NDN is from the edge networks, such as the IoT and mobile scenarios. But the main problem so far is I feel the deployment is blocked because there are some connectivity issues, such as when I run my NFT on my iPhone, I run the NFT on the laptop, but somehow they may not connect to each other. Although I have Wi-Fi, but in the Wi-Fi, there are lots of things that are blocked, like the unicast under the Wi-Fi, the multicast under the Wi-Fi. So I think maybe the connectivity, if we can solve that problem first, that would be very helpful.
So is this, when you say connectivity, is this existing infrastructure or is NFTs?
So it's
So
like
is it
I can give you one example. Like we wrote this poster at the last year's ICN conference. Basically, if you want to directly utilize layer 2 to run NDN on top, you cannot do it. Today's IP implementation really created the obstacle. The systems like Apple, Android, whatever you name it, do not give you access for you to run directly on top of layer 2. With this, the pairwise things we tried, just nothing works. I think that I almost was thinking about writing NSF a memo to say that they encourages the development of the future internet architecture. Yet at the same time, in parallel, the people doing system research are now helping us to actually enable the future architecture. Instead, everything's still built on top of IP. I mean, if you want to find the alternative to IP, you have to open the door for the alternative to try it. And for now, the door is completely shut.
And actually, what Lixia referred was limitations of operating systems. But I think what Teng meant is actually broader than just operating systems. So a lot of our infrastructure, like wireless access points, wireless access points, even though the wireless communication is broadcast, it is optimized for the IP to operate, and IP is doing the point-to-point. So therefore, a lot of things in access points, especially all the Cisco stuff, they just don't do any multicast. Like they prohibit you communicate with others on the same subnet because IP doesn't do that. IP doesn't need. You always go to the cloud. You never communicate locally. So that's kind of another angle to add to what Lixia said.
That is IP feedback into itself. I think the reason that you don't allow two IP hosts to directly talk to each other is because of security problems. One infect another with the viruses. So you set up all these constraints. The reason that you easily infect another device is because IP TCP doesn't really have security built in. So all the ports open, you can just submit something and infect the machine so easily. And therefore, they make it a further stovepipe. Everything can only talk to the cloud. And that the further set the obstacles for you to try out the new things, which has security built in. I think those are really the limitations. But you should answer this question. Where we are.
I think we veered a little bit off the original question.
that's fine.
And the question was where we are. I think we're still in the research stage. So yes, we have a number of software platforms that people can use to run experiments, but the protocol is still evolving. And the most important part for the kind of at this particular stage is to have real applications to try them out, to realize and to start playing with. Like if some protocol changes are needed for the application, they just needs to be done. If we can support additional wireless protocols, we need to try to support them. There is advantage for this IoT environment because IoT operating system, or operating system in quotes, don't really impose any constraints of what you can do. So we can leverage NDN to the greater degree than we can do on iPhone. For on iPhone, we can't really do anything at all because it's kind of completely closed platform. So we can do a little bit on Android platform, but it's kind of, again, pretty much closed unless you jailbreak it. So I'm trying to remember what the point is.
We're talking about IoT stuff, where we stand.
So from my perspective, we're still at the experimental stage, like pretty much a research stage needed, but we're slowly going towards some interesting areas where ICN can be really, really useful.
Okay, it's now my turn. I think that, yeah, I agree with Alex. We're still in the research stage. So the question is, how come we are still in research stage after so many years? If we don't start with Van Jacobson's 2006 first Google talk, which is already 12 years, we start with 2010. That's where the NDN project got funded. What happened over these 8 years? I think that's a question we should ask ourselves. There's multiple answers. First of all, one should understand changing architecture is a grand challenge. The people always say grand challenge. I don't think others are, but this one is. And then I think most people in this room just look too young, so therefore you don't know much about history. How long did that take for TCP/IP to mature? Do people know the answer?
30, 40, 40?
Yeah, so 100 is exactly. But the 50, I think, is not too much off the scope. Because the ARPANET started in the late 60s. By 74, if we don't count ARPANET, by 74, everyone agrees that Wendy Cerf and Bob Kahn published that seminal paper about interconnection of networks. That laid the foundation of TCP/IP. That's 74. And until people on the street heard about the TCP/IP, that was the 80s. That was the early 90s. So it's about 20 years. What happened during these 20 years? So from 74 to 81, that's where the basic TCP/IP specification came into existence. And what's missing in those specifications? So it takes 7 years from 74 to 81. What happened during that 7 years? The model changed. In the 74 paper, Cerf and Kahn proposed there will be an internet layer, just one protocol called IP. In that 7 years, people sorted out, okay, there has to be internet layer, and there has to be a transport layer. So that changes the things. So there are also other changes, less known. That is, the earlier proposal said we would use variable length address, just on the side notes. Had we not adopted this fixed length, we may not have had to go through all this IPv6 trouble. And it really says that early on, try to optimize performance may not give you the right choice. But anyway, from 81 until later, when web came along, what happened during this time? The protocol matured. One thing everyone knows about is that the original TCP specification published in 1981, this RFC 793, does not have congestion control. So then we run into horrible congestion collapse during the mid-80s. I was there. You literally couldn't do anything during the day. Until Van Jacobson fixed it with the slow start. So the congestion control was added after the protocol already standardized. What other things got added? DNS. Then we added BGP. That is inter-domain communication protocol. How did people do networking without an inter-domain routing protocol? Well, you have to understand the whole thing was funded by the daddy defense. So it was not interdomain until commercialization happened in the mid-80s. Now you talk about, okay, this is your network, this is my network, a packet across borders cause money change hands. So you need interdomain routing now. So from 81 to early 90s, during this like 12 years, 13 years, depending on how you count it, the protocol suite really matured. How? Through usage. Through kind of a small scale usage. I call it small scale because the users on the network at that time, universities, very few other commercial organizations. And those usage drove the problem on the surface and people solved it. So therefore, when Tim Berners-Lee invented the web in particular, when UIUC invented this, what's it called? Mozilla? No, Mozilla.
Netscape. No?
Huh? Mosaic. It's a Mosaic. Yeah. It's a graphic user interface. Then the internet exploded. In the early days of www, the interpretation is a World Wide Web.
Yeah.
With all this preparation, I mean, TCP resiliently produced data, delivered the data, and yet we still had the problems. Right? So architecture changes takes lots of time. And in particular, it requires real deployment to actually discover the problems and fix the issues. Even for the NDN team, you may not agree. There's more focus on building this forwarder and much less focus on the applications. And there's more people working on the forwarder than the people who work on security. I think I agree with all of you said about we need to focus on the edge. And yet, look at the focus. We haven't had much focus on the edge yet. But the NDN team made a decision this year the focus will be on the edge. Why we focus on the edge? A few good reasons. For one is that's where TCP/IP has the most problems. Look at how you do IoT stuff. They just bring the TCP/IP protocol stack into the IoT environment. You know that the TCP/IP was designed for so-called mainframes. For the IoTs, $1 each devices, it's not fit. It doesn't fit. It doesn't scale that well. There's no security. It's very complex. If you have security, you have to do the TLS, the DTLS, which are not designed for the small devices. The second reason is that it's actually, I should say, this is the first reason. Observing history, how you can get new things out. You need lateral deployment, and you need lateral gain. That is to say, if you want to do something new, you can do it without necessary coordination with any other party. And you have the gain if you do so. The best example I can think of, you may not think it's a good example, is network address translation. For people, and I see a few faces, we go IETF. We all know that IETF hate NET for many years. But how come NET, just like a wildfire, get deployed overnight instantly everywhere? Because the unilateral property of NET. If I put a NET box there, nobody knows and nobody cares, and I don't need to get anyone's permission. And I instantly, behind the NET, I can plug in many machines. I don't have to apply for the IP addresses or anything else. And I have the gain. I decide to deploy, and I have the gain immediately. These are the properties to get any new things out. And only if you work at the edges, you can gain this. You do your home IoT, you decide, right? Nobody else can decide for you. If the Indian community can provide such a system to say, okay, here's a package. You can try it out at your home. It's secure. You get the local trust anchors. So nobody really dictates your trust policies. And you prove the security. Then maybe my home going to buy it. I don't need permission from others, and I hold my gain. These are the example of edge deployment that will get the NDN out.
Okay, sure. Just very small thing on top of what Lixia mentioned about kind of unilateral deployment of ICN. In addition to that, I think we should, as a community, focus not on the replacement of application. Like we have some web application that is working reasonably well. Kind of the focus should not be just creating like web-based NDN, but rather have some applications that are unique for NDN, like something that is not possible or like extremely hard to implement in a TCP/IP environment, which is obviously applies to all the edges where TCP/IP doesn't work. Potentially applies to scientific networking where you need some different properties. Okay, that's very small comment then.
So I also think that the ICN and NDN are still in the research stage, but there are many solutions for the routing and forwarding. Maybe so this issue would be solved in the near future. But so I think there are two missing issues. One is the security. I focus on the privacy anyway. So in NDN, so maybe so the names are open. I mean, so names are not encrypted. If okay, we can encrypt the name, but so names are open. So maybe so some private information is leaked from the names. So maybe so the IP, so HTTP or TLS. Maybe session security provides the names are hidden. So maybe so this is the main difference from the IP and NDN. So or maybe so this is a drawback of the NDN ICN. So we should solve such issues, privacy leakage issues. But so the researchers who tackles that issue is very small. So maybe in any ICN conference, maybe there is one or two papers. So anyway, this is the first issue. The second one is the naming scheme. So currently, NDN uses the hierarchical name like URI. So I'm not sure the hierarchical name is best or not. So maybe a kind of maybe tag routing or more flexible naming is required to. This is the second issue. So as privacy issues and naming issues are important, but so the few researchers attack these problems. So this is my understanding.
So is this something that you think it's in the protocol or in the architecture itself? Or is this something that can be worked around? Because NDN, and there are some proposals that had flat namespaces and hash-based names. For those, they still have some of the ICN or NDN properties, but they don't need hierarchical names. There are, of course, trade-offs between flat namespace and hierarchical namespaces. So do you think this is something that can be solved at the application layer, depending on what the application needs? Or is this something more fundamental? Because
my interpretation of Toru's comment is that we haven't done much research on naming, that we should. It's really important to put our effort into naming, that we haven't done much. I agree with you completely.
So I personally work with a few scientific communities. So yes, I completely agree that the naming is hard to do, but it's also very hard to get them to agree on anything because they don't know what the application names or content names should be. We as a researcher can go in this, say the name should be like this, but I don't know if we can enforce that. We can say if you don't name it, you don't get the benefits of ICN. But I don't know if that's motivation enough.
No, I think that the fundamental question to me is that we haven't really put much effort into understanding how to develop this name structure. I don't think it's hard. I think if this is, to me, the most interesting part of NDN, because we say we name data. It gives you lots power, lots of flexibility, but there's also the greater danger of going wrong. You can make the name like 500 bytes long, and who's going to use it? So I just said we need to put time to work on this, develop some kind of naming convention standard or default. So people who are new to this, you can start with kind of cookie cutter thing, then you tune based on your own application features.
And maybe like a comment. Go ahead.
Yeah, thank you. The point is that I also agree that investigating naming scheme is a key topic in ICN research. We should stop investigating caching, for instance. And yeah, the point is that naming are application dependent. And if you isolate a kind of vertical, the way you standardize the naming space has an impact on the performance of the network. And this is a pure research problem that we should face with some novel conceptual framework. See? To the best of my limited knowledge, in the example I studied so far, the community proposed some naming scheme. Also, there have been some efforts to propose some meta scheme that should adapt to different contexts. But we are still in the stage where we are trying to understand the way we name objects impacts on the network. And this is clearly a very great challenge we should everybody focus on. Yeah. This could be the first goal we should try to target.
And actually extend what Luigi or Alfredo?
Alfredo for friends.
Okay, so Alfredo. So Alfredo mentioned that naming data impacts the networking, but it's not just networking. As Toru mentioned, it also impacts privacy. It impacts security because name defines the security context, like what this object is for. So therefore, I agree with everybody that the research on naming is kind of effectively critical. I mean, we could go to completely bad direction and try to design naming that reflects IP, very similar to IP properties. So that the whole thing can be obscure, like only like a domain name or like something like IP address would be visible on the networking level. But then we're losing networking part, like maybe gaining some privacy. For the security, there's like nothing because there is no context it can be defined. So we have to have something meaningful. Actually, I like the phrase you mentioned, like innovative approach to design naming.
Yeah. So this echoes back to the question that Susmit asked: where we are, how mature. We can see that there is a fundamental research areas we haven't put enough attention to. So that's how mature the things are. I think we really should speak out loudly and make everyone understand. NDN is not just a fancy CDN, but that's where, unfortunately, the majority of the effort the community at large has gone to. Caches, CDNs, cache lifetime, all of this. But the power, I agree with you completely, and Alex and Toru, that naming is a fundamental, is probably the most important thing that we need to put the research effort on. Naming ties together three things: application usernames, forwarding usernames, and security usernames. So when we had a joke with the Van Jacobson, we said, yeah, NDN is so great, except that you make the naming damnly hard. You just combine everything into one. Now, you say if you can do naming at the network layer, great. You can use naming to manage, control your securities, is great. And of course, application usernames. When you put the three things together, and that's where the challenges are.
Yeah, it's actually 4 because transport layer also is in there.
Right. Yeah.
Okay, so if the audience has any questions, we'll take it.
I have a very basic question. When there was NDN, it was new and people did not think about the security only to the content. But there has been so many attacks, even the cache pollution and the forwarding information-based pollution and so many attacks. Signing is something which we provide only in the data package which we send to sign the content, and even the intermediate routers do not check the sign of the content, so content can be polluted or so on. But what is there is one thing which was mentioned on the Indian side, we can sign the interest as well. So I could not understand how does it, is there any application of signing the interest, or what is the purpose of signing the interest in all this context? Does it serve any purpose, or is only just signing the interest?
You have to think this way. If an interest only retrieves a piece of data, it has no side effect on the producer than anyone else. It just gets this piece of data already exists, move. But if the interest is used as a command, like in the LT environment, you turn on the light, that needs the authentication and authorization, and that's why signing is required. So the signed interest meant to serve different purposes. It has side effect. It has limitations on who can do this. Then you have to sign the interest. So if you just purely retrieve the data, you do not.
It's only for the administrative, we send the administrative command purpose for this interest, then we need signing. How about if we request any data and to detect either the node is malicious or not, or who is sending the malicious interest or not? Is there anything?
I don't think you can use a signed interest to detect the malicious node.
Yeah.
But also, I want to clarify one thing. You said earlier that you say, oh, there is a cache poisoning that has happened many times. I have not heard of once.
No, but there are so many papers which are talking about.
Right. That's about people who want to produce papers. But
And
my blunt opinion.
Those papers focus on caching.
Right.
Yeah.
Yeah, and they ignore completely the fact, for one, NDN has a secure routing. So it's actually extremely difficult to put the poisoned data into the cache to start with.
How about the FIDs? If we just delegate our prefixes, name prefixes to forward the data, and the FID is polluted, or some rogue prefixes are there to forward the.
So sorry that I interrupted you, but this is exactly what Lixia mentioned.
Yeah.
To add thing to FIB, you have to have a permission for that. So there's a whole secure routing infrastructure, but it's not that easy to put FIB in there. I mean, and because there's not that easy to put FIB, you have to have permission, like everybody has to trust you that you actually own this content effectively. I mean, to have permission that you can announce this prefix. So, and kind of this gets back to the caching. It's not easy to put FIB, not easy to pollute the cache.
Indian SIM, is there any provision for all these libraries? I've never seen, I've never used the Indian SIM exactly for security purpose, only for the routing purpose. So I never checked. But is it available in the Indian for all these libraries for this?
I mean, the question is what exactly you want to do, simulate in NDN SIM. I mean, it's a simulation environment. I mean, it's based on our main code base, so it can always do actual signing, actual verification. It's just not necessarily meaningful in a simulation environment.
I never used for security purpose.
So we'll take the architectural questions later, but let's focus on the
This was simple questions.
Yeah. So any other questions? Okay. So both Alex and Lisa mentioned the age. So let's just go back to the. So there is an assumption that if we deploy ICN at the edge, that translates well into the core of network. Is that true?
I don't. Sorry, I don't think so. I don't think so, because edge core are.
So my question is showing that NDN works well at the edge sufficient to say that NDN works well across everything?
I don't understand the question. Maybe you can clarify. What do you mean by works well across the core?
So
What is the core? Core just carry the packets.
sure. But they have, so when it comes to IoT, I can show that IoT is secure at the end. Does that mean that when I transport it over long distance links or through a bunch of interconnected routers, it's still secure?
The security goes with the data. It doesn't matter how it.
I mean, the
far it
answer
goes.
may be yes. I'm just asking.
Yeah, okay. I want to clarify the question.
When we talk about ICN at the edge, we should clarify what we are talking about. Because if we run ICN at the edge, are we thinking about ICN as an overlay established between edge points of an IP infrastructure? Should we care about between ICN and IP interoperability? There are some examples, for instance. This is a research domain. Are we starting with, perhaps a good selling point of ICN is the edge. It's okay. But are we doing that because we know that in the core, perhaps, there are scalability problems with longest prefix matching? Which is okay. We should start from our strength. And also, the selling point of ICN on the edge, or in standalone application, for instance, Internet of Drones. So that could be another topic where ICN should be spent with great advantages, because in that case you have an isolated network. And so these are my considerations. So ICN at the edge implies that we are going to study the interoperability between ICN and IP, because if in the core we are using IP, we should do something to translate ICN to IP and IP to ICN. And in order to address this issue, you need to add further functionalities. So perhaps we could risk to make the architecture more complex. So we could lose the lean design of an NDN, for instance, with interested data packet that can do everything for us. And the overall architecture could be a little bit cumbersome. And the people could say that future internet is IPv6, for instance. Right. A lot of people say that. So these are my considerations.
I agree with you that NDN enables new applications, and we should take advantage of that. Really run NDN over layer 2. I think if you run NDN over IP, you get a problem of both. What's the point of running NDN over IP other than, well, we don't have access to layer 2? But then NDN is just a wrapper. It's not, but IP in this case is just a wrapper. It's not anything meaningful. I don't see how the applications natively based on the NDN would be so-called isolated. Give you the example of in the early days of IP, there's just few IP nodes, a little here, a little there. Were they isolated? They're not isolated at all. They reach each other through dial-up over the telephony infrastructure, but they create a connected internet, however small, how far away they are. So I think that's how the NDN sees the picture. That is, we don't really care. There's a vast network called IP. To NDN, it's just a long link. So you can use the UDP tunnels, TCP tunnels, IP tunnels, whichever way works to connect up all this isolated NDN island, create an NDN network. That's how the current NDN testbed really is. We cross the 4 continents, but we don't really see, we cross IP. We don't see it. And therefore, there's no such a thing called translation. And consequently, there's no worry about increased complexity.
Yes, but when you scale up to exabyte contents, cardinality, your edges should be able, if they have to cross an IP island, very big IP island, they have to be able to understand the egress point, the ingress point, and for this they have to query a kind of DNS for some translator from names to addresses, something like that.
You think about how IP set up tunnels, right? It's you can auto-configure, you can configure, but those are hidden, really hidden from the IP layer.
Try to answer this in a slightly different way. If we get to the point that edges would generate exabytes of traffic, it would be good enough business for ISPs to actually support NDN, and then we definitely would succeed in doing everything natively. Unfortunately, we're far away from having that amount of traffic, and there's effectively no, as of right now, there is no business for ISPs to do any support, and therefore we just need to focus on building application at the edges, at the layer 2. Whatever, if we need some interconnection between islands, we'll do some form of UDP tunneling or whatever is supported. When we get into the stage of exabytes, the problem should be solved. I mean, will be solved either by itself or some natural way.
There are two things I want to emphasize. First, when we say edge, let's not think about, oh, this is an edge network. That's where all the data gets generated. Without data, there's no need for core. With data, we don't care about core. The core will take care of themselves, whether they're going to stay just to provide the IP tunnels or whether they're going to actually run IP natively. The market will figure out, and we don't have to worry. For us, produce applications, solve people's problem, generate data. That's our job. Core, who cares?
So I think
the market will take care.
I think we have a little bit different definition of the edge. So, would you say when the CERN Large Hadron Collider generates the collider at CERN that generates a petabyte of data a year, is that still considered an edge?
As applications, yeah.
Okay. Okay. So we do have application use cases that generates a petabyte of data. And so my question was, if we start with IoT assumptions, then it doesn't.
We're not starting with the IoT assumption. IoT is a popular edge application, but that's not only edge.
Okay.
Okay.
I think Toru had some questions.
Yeah, I guess Alfredo what Alfredo has in his model is from IP world you want to control NDN world or ICN. Right? So in that case, we need some interpretation between translation. But if both sides are ICN, then we don't need any change of the model. We just have links between islands of ICN. So yeah, so that makes a big difference.
Yeah, I truly understand what has been said, and I agree that could be a starting point, good starting point. Let's don't care. We can set up a tunnel, and it works. But it is a good starting point at the moment where we have to network different edges. We need the automated systems, and I think that I don't know if tunnels could be a scalable solution, but let's wait and see. The market will solve the problem. Perhaps in the meantime, this could be a long-term research topic, the interoperability. I don't want IP to control NDN, but if you want to start doing NDN in the internet, you have to face NDN IP interoperability somehow with tunnels to start with. But if it is successful, the ICN as a solution in the edge, you will have many edges. Perhaps to handle a smart city application in a very big city, you have to set up many edges for many verticals.
What do you mean by setting up many edges?
Yeah, for instance, you need an edge network for intelligent transportation system, another edge to handle pollution data, another end for smart grid.
There shouldn't be. NDN is a network layer. All of these are applications running on the same network layer. They're not as separate
network layer, but you cannot install a network layer on iPhone or any other devices. So how can we create edges at the network layer if we don't have devices that can run NDN at the network layer? I like NDN at the network layer, but we have a technical obstacle nowadays. We should run with our self-made board to have NDN at the network layer. That's the point. So this is clearly a technical obstacle. I don't know if I'm missing something. I'm sure that I'm missing something. But how to solve this problem? How can we run NDN at the network layer if we don't have commercial devices for doing that? How to scale up edge application at the network layer without support from commercial devices? We can set up academic edge networks where we program things, a few devices, but we need to scale up. So how to?
I mean, if we show enough benefits of NDN or ICN, they may want to catch up. I mean, we cannot force them to buy this idea unless we show this is good.
I'll give you another example. Startups. They build the edge networks. They use NDN plainly. They don't care the other things. There is this one startup called Operant Solar. They build a mesh rooftop LoRa network, just a pure NDN over layer 2. And they build their things. Yeah, then they can have gateways to connect to the rest of the world. But for their goal, this pure NDN low rate on the rooftop works just fine. So that's why I said earlier about my unilateral property, the unilateral gain things, it applies. That's why edges is really the place where you have low resistance because you decide. You have the highest gain because you get what you want. For anything, you get intermingled with the deployed base. You have bigger challenges.
So you see the convergence between, for instance, IoT application based on IP and IoT application that will be based on NDN at the application layer. So they can converge data from these two architectures will be merged at the application layer. Because if you have already installed IoT application based on 6LoWPAN, you won't reconfigure 1 million sensor. Perhaps they will converge at the application layer.
Yeah.
That could be a solution.
Yeah. Do not change or disturb any deployed base. That's what I learned from IPv6, 20 years of lessons. IPv6 said, V6, V4 you go out, so V6 I can come in. That is a bad idea.
And as like a random example, in UCLA, there's like building automation, whatever facilities. They use so many different technologies. Like they still use technology that they deployed like 20 years ago over like serial lines that support like 1 kilobit per hour or whatever. So those things that have been already deployed, they will be deployed. They will die at some point in the future. But the new things will appear as pure NDN solutions, and that will have essential benefits to the system. So I don't. Just small comment. I don't see there's a kind of convergence of the application layer, just like evolution of the system.
Yeah, correct. So the second suggestion we can give is, the first one was to stop investigating caching. The second one is to stop investigating ICN as the overlay, as an overlay.
No, I don't think we said that. Like, I think the suggestion is a good.
I would rather say the same thing, but in a very different way. Stop doing research for the sake of publication only. you really do the experimentation, then you publish. You do not pick the next paper topic because it's easy to do. For caching, I'm not saying you stop investigating caching. Once we have data, definitely you need to look into caching. The question is, before you have data, what do you even do caching research on? Where does your data come from for you to do research? So it's not so much we say you stop investigating caching, but there's no cache to investigate. There's no data there.
Yeah, but if I am a young PhD student, I have to decide whether to invest on an experimental platform for with the NDN at the network layer for edge computing, something like that, or NDN as an overlay, perhaps. Clearly, there is no definitive answer, but in a general sense, we could promote the experimentation of NDN on the layer 3.
I mean, NDN is a networking layer. It can run on whatever.
Yeah.
Whatever is available. We can use IP as a layer 2, but just emulate the same thing.
So NDN is a layer 3. I didn't get your question.
So I wouldn't say we promote anything or we don't promote. We just need to promote use of NDN, like as a networking layer. What is exactly underneath? Whether it's IP or is it raw Ethernet or is it? I forgot what was in this drone paper that was presented. There was some, I guess, another layer of communication. It doesn't matter. Like, we just need to work out this NDN communication, and if you need to cross a longer distance over using actual IP overlay, okay, that will be just accident that the NDN runs over a bit longer distance.
Okay.
I guess calling it the edge is kind of misleading. It's not edge, but it's a whole network in a sense. You mean yes, right? IoT island somehow, and so there's no core or edge. It's a single IoT network island, and everything is there, and that island can be used for different applications. All different IoT devices are included, and I guess this strategy is really good because IoT network is coming and also 5G is coming, and so it's in the trend. And if we miss the trend, I'm kind of worrying that what the next wave can be. So and I guess it is fine to publish papers producing research results, but we should attract more people and who are more interested in really implementing in IoT network using this.
Yeah, I by no means I'm against publishing papers, well-published papers. The question is, if we do the ICN research, only published papers, this doesn't move ICN forward. We need to build useful applications to move the world forward. So you do the imaginary caching paper, that doesn't help you move the ICN forward because we don't really have data to validate or invalidate your results.
So I have a related question, but I think I already know the answer from the discussion. What kind of transitional technologies do we need, or if we would need anything? I think we talked about this a little bit in the previous session.
How do you define transition?
So something ICN coexisting with IP, should there be an interaction between them, or they should be just side by side working on their own? And as Alex said, like some 20 years later, one would go away because it's too old.
I may give an example that's related to what I'm doing now. So later I will give introduction on our paper, how to analyze email access. So your email application on your phone can talk to your email application on the laptop. So today's email application, they are not smart enough to talk with each other because of the IP network. You only have to talk to a predefined server. But within NDN, you don't care about that. You only care about data. So you can enable this off-the-grid communication. In our work, the email application is still the existing email application. It can talk to the email server by default through the IP infrastructure. At the same time, it can also talk to a peer which uses NDN networks. So I don't see there's a conflict. You can just have both to have extra features. If it works, then it works.
Perhaps one possible path of the technological evolution is to have two parallel networking systems. And if you need to run an application that take advantage of both, you will solve at the application layer interoperability. This could be the integration, not interoperability. At the same time, for instance, if we look at the PV4, PV6 transition, there are plenty of standards to handle the internet work between PV4 and the PV6, but these are protocols that designed with the same design principle, the host one. I don't know this interoperability between NDN and IP. It's fascinating to investigate, but perhaps I don't know if at the end of the day could provide us with results that could be really spent if the technological path will go towards a couple of distinct infrastructure and architecture that don't want to talk to each other and won't talk each other, but simply integrate data at the application layer.
For example, IoT network is used. I guess many IoT networks do not use IP. Even now.
Yeah.
So
They still pipe using other things like Zigbee.
So there we can use NDN instead. Oh. So, but it is connected by using gateway. So
I agree to you that, for instance, ICN with IoT is one of my key research topics now. The point when I have to sell NDN with IoT for a research grant, it's great. Okay? It's great to write. When I have to sell NDN plus IoT to a company that is to develop its own infrastructure tomorrow, I cannot sell yet because we are in research stage. And I have to fight against 200 standards that try to address IoT connectivity at the network layer or any layer. So we, in this case, ICN plus IoT will be another way to let IoT devices communicate each other that is to fight against further 200 architectures. So we have to be very strong. The advantages should be so high to completely, let me say, destroy it, in the good sense, the competition. Okay? Perhaps it is even worse because it is not against IP. It is against 200 competitors. It's a different problem.
Just very quick, you guys means Lixia, Professor Lixia, and you are working means dedicatedly on the project. I have a very simple question. He's asking there about what is the next technology, but I'm not asking that one. I'm just going to reverse this question in sense, what do you think is the way forward, or in the future you are looking toward the applications? You are looking, because you are working on the forwarding. Caching is the old, so many people work on the caching. We are not concerned about the caching, and forwarding you already did a good job. So what next you are looking forward from the research community as well as to your point of view, what should be we are looking in the NDN point of view in the near future?
We said that edges, but I think Professor points out maybe edge could be misinterpreted. Applications, security, usability, i.e. auto configuration. I think you really have to produce useful applications to demonstrate the superiority of NDN. Yeah, yes, in the past we put lots of effort into the forwarding, which may be necessary, but I think for now it's really about building applications, building lots of different applications, and to really show that this architecture is a general one.
It means now we have to develop applications to test the viability, or maybe before deployment we want to test this at an extensive level. So is it good enough to use as NDN in the future or not? So it means now we have to actually test by using or by developing so many applications so that we can check it.
That's how IP came out.
Yeah. So it means now this is the point where we have to go forward.
We have to go forward.
Yeah.
Like those guys building the NDN forwarders, but look at their phone. It doesn't seem to be running NDN for data delivery yet, and we need to change that.
So that's why I'm not asking Alex, because he's looking at his phone.
we really need to build the application and really use it. That's how we can improve the package, make it really secure, make it really usable. And again, we had an Indian retreat really this week. And people said that you download the NFD, install it, you still have to do configuration before you can run applications. That is not acceptable. We have to do auto configuration. And we can, just we haven't done yet.
Yes, I just want to re-emphasize the same topic. From the research perspective, from the networking perspective, we have to do kind of very reliable auto configuration that is as easy as the just kind of plug and play fashion, so you can enable networking communication in some fashion. The same ways should apply for the security, maybe for privacy, if that application actually requires privacy.
Yeah, I agree with these two. So maybe we need applications, and also when we design applications, we should focus on the special name schemes special for some applications, and also provide some privacy and security issues. So currently, my project is focusing on the communication in the disaster fields. So in that case, there is no networks are disrupted, so there is no single naming scheme. So many teams should create new name schemes, but packet should be forwarded to another network schemes. But also we need some privacy or security levels of different name schemes. So anyway, what I'm saying is that we should consider applications which leverage or exploit the good naming schemes. Okay, this is my personal opinion. Anyway,
because naming is the core of this NDN or ICN. I know that since last 4 years I have been working on this one, NDN and ICN. Naming is still NDN community is unified that we have to use the hierarchical naming and so on whatsoever. But there are so many other variants which are in the under discussion. Still, there's no standard. Yeah, there should be some standard. Like, I'm not talking about the IEEE standard or something standard, but the standard naming scheme to be used so that tomorrow, if I'm going to use auto configuration, for example, developing any scheme or the application, which naming scheme should I use? Maybe another person using another scheme, a naming scheme. Professor is using disaster for something other applications. He's using another naming scheme. Then how can we come up to how can I say resolve all these things? This is I think one of the.
Well, I think the names, application defines it. So therefore, it's not absolutely necessary. You agree on, you have 7 components in the name, and I can have 8. That's okay. It's fine. But I think that we should develop the guidelines of, the basic naming schema to guide people to say if you develop applications like this is how you name your data, because that's the experience we accumulate after this several years of trials and errors. I hate to admit this, but we were supposed to write this paper on Indian naming to submit it to the ICN 2018. We just failed. Yeah, but we will write this.
Just a small comment on when you say that applying ICN to IoTs, those kind of things where we have heterogeneous devices. My concern is that, of course, this thing has to be investigated at a certain point, but when we talk about devices with very limited lifetime in terms of battery-operated devices, and also when we're talking about, let's say, Zigbees or like those sensors where we are trying to build some applications, but they have very low computation power. When it comes to apply ICN sort of architecture that involves several checkpoints to process the interest packet, and also when the data packet is being traversed back to the consumer, what do you think, what would be the impact on the power consumption of those devices? Because this is one of the important factor when I'm writing a research proposal. I have to mention that how ICN can mitigate the power consumption, let's say?
Well, number one goal is that your device doesn't get compromised. You can have very efficient data communication if easily they just scan your port and compromise. That efficiency doesn't do you any good. So therefore, you must have a secure solution. Now the question is only how efficient you can make that secure solution work. We did this Indian riot. We don't do standard public key verification. We do something different. But this guy knows it more detail than I do. So you have to understand what the goal is. If the security is required, all you can do is optimize that security implementation, not to say get rid of security.
Yeah, but okay, I understand that point. That of course the objective could be of secure content, and the system should not be compromised from that perspective. But I would reiterate my question that how should we be able to define the impact of applying ICN on the energy consumption of, let's say, sensor networks? If we have sensors with limited batteries and limited computation power, we say, okay, ICN is going to make it secure. If we deploy ICN, let us assume that, okay, this pitch is going to sell out there, that, okay, ICN is going to make this network more secure. But at the cost of what? What is the cost that that network has to pay? Of course, there is no free lunch. So what is the cost? Is it power consumption, or like how things will work? Because if you're applying, like Zigbee protocol is already out there, things are communicating very well, right? But always there's a research about energy consumption of those battery-operated devices.
I normally would say there's no free lunch, otherwise I would eat a free lunch every day. But in this case, I honestly tell you, I fail. I can be wrong. I will prove I'm wrong. But I think by this time, you're changing the architecture. You actually got a free lunch as far as the energy consumption is concerned. Look at today's IP communication model. It's a point-to-point. So if we want to set security, you get a TLS, DTLS. It's all multiple packet exchanges. I think the NDN, I wouldn't use the word ICN because the two mean different things for me. NDN focus on data. It's the semantic naming gives you the savings. The name is built into the application. Your sensor devices actually get the semantic name built in, and that's from there you can reason about security. You don't have to do the handshakings, establish keys, but it's inherent in your system already. So that I do not believe it's going to burn you more energy if you have optimized your security. I would say that it would save your energy compared to equivalent security level, but you do it use the TLS connections.
And if I add the one more thing that may not be directly answering your question, today's IP stack, or whatever, Zigbee stack is way more complex than NDN stack. So you would be having some part of the free lunch just replacing this much of stack with this much of stack.
Right, that's what I meant. Yeah, by the architecture.
I mean, you would probably use power for other purposes, so you're not going to have real free lunch, but at least for the pure stack processing or data processing, interest processing, that would potentially would have a smaller energy footprint than the IP or whatever the other protocols.
Yes, we'll go there.
Okay, go to the professor.
Another possible saving in energy is that caching. I mean that the sensor can push the reading to I don't know, like a base station or some access point, then immediately go to sleep. And the cache data is signed, so it's secure. So I guess that's another possibility.
I completely agree with Alex that a lot of the complexities in all sorts of communications, 5G, IoT, ZigBee, a lot of it is much simpler because you don't need all the plumbing because of the point-to-point communication. Once that goes away, that gives you more room for doing intelligent stuff with the network. but you don't need as much power.
I was just wondering that do we have some studies already available who are actually taking this thing into account, where they're trying to compare the energy consumption, for instance, of those heterogeneous devices without applying ICN and then with applying ICN? That could be a very good study.
I think there were some initial studies, but they're not yet fully complete.
Yeah, another point is that if we are talking about ICN IoT, which is a great topic, is that, for instance, there is a 6-LoWPAN standard, which is something very successful, a lot of efforts put in place to develop this standard, is able to compress IP packets to fit 127 IEEE 802.15.4 standard packets. So clearly, it is a challenge if you want to run ICN end-to-end on top of this standard, perhaps in scenario where modes should be awake for 1% of time. So in this case, perhaps you cannot leverage caching, also because these modes do not have memory to cache. And so we solve also the problem of investigating caching. But it is a challenge, really, and this could be another topic that this could be investigated. I agree to you. It is not immediate to fit a name written as an URI within a packet, in a so small packet, where ITF spent 10 years to study how to fit an IPv6 packet inside. So it is a challenge that we have to face. Clearly, we have since IoT applications are information-centric by design, this is something I think everybody can agree in 90% of cases. I think that if you are going to use an architecture that naturally fits the application requirement, this could bring some advantages that could compensate some other problems, like one of fitting the names to this very small packet without using fragmentation, of course. And it's a challenge, and that we are researchers like challenges, so it's great.
So we are almost out of time, so it was a great discussion. But we will finish, this is a question to the panelists as well as the audience. So what is the status of deployment of ICN? I know about the test beds, but Lisa mentioned some startups, the companies, so where are we?
I wouldn't call our Indian test bed as deployment. Okay, let's forget that one. That's really the playground for you to try things out. It's not deployment in the sense that that doesn't serve any useful application. It's just a playground.
So are there any useful applications that are using ICN or NDN currently?
To my definition, the real deployment means really serving user apps. I don't know any, to my knowledge.
I mean, Upper and Solar would be kind of one starting up example.
They're starting up. They're not deployment yet. They're still in trials. And then, like I mentioned, from 1981, actually not in 1981, IP really put into action in 1983, January. It's TCP/IP switch over. Everyone ran it, and it failed miserably. It took a long time to fix it. But from 1983 until, say, 1993, when the web came along, as 10 years, that's really deployment. The real users use them for real applications. And, you run into those horrible problems, and you fix it.
So I think we're at the time. So unless any last minute, there are any last minute questions.
I have more of a comment than a question, and I agree with the panelists talking about having probably we won't since naming scheme of data affects the privacy, security, the network caching performance, and all that. There probably won't be a silver bullet, implementation saying use this naming scheme and it'll work for all. It's obviously application based, like Dr. Lixia mentioned. So having enough efforts from the community with enough studies about what kind of naming scheme and what kind of gives what kind of caching performance versus security and privacy, and having the Indian team
evaluate, and having them on the website might help deployments and adaptation by new startups or something, where a healthcare application startup could say, okay, we don't care as much about caching performance, but since this naming scheme gives less caching performance but more privacy security performance, so having those lists of trade-offs, say green zone for privacy and stuff like that, would probably help in adaptation, and with enough research from the community and stuff, developing applications for different naming schemes. So I agree with that, and you saying that we need more novel architecture kind of, suggestion that you had in the for the first question makes sense. Instead of just having a novel architecture, it makes sense of having a list of different naming schemes available and what their advantages and disadvantages are. Thank you.
So, any other questions?
I think if we start putting more focus on the applications, we will run into the naming space. If we only build a folder, we don't really touch naming much. But we build applications, and the first question you must answer how you name the data for this application. Then you do enough, and you can extract out the commonalities to see the rules.
So the problem would be that even the application users or the communities, they haven't been able to agree on naming themselves. That makes it a little bit awkward.
But each application can define their own names. They don't have to agree on. It just said we want to learn from every trial, from every application. How did you do your naming? What's the advantages and disadvantages?
Yes.
So we can extract out the commonalities.
But even with applications that has a defined naming scheme, it's often not enforced. So you have a user using the same application having some mandatory components missing from the name. And that works out currently well because IP doesn't care about the name. With NDN, that is not going to work. So the communities have to get together and figure out how they want to name their things. That's not very easy.
I don't think I follow your...
Yeah, I think you're kind of referring to your climate work.
Yes.
I'm not 100% sure that it would be the same in NDN environment. So, for example, like our toy applications that we had, they actually enforce naming. Like you cannot not put sequence number at a specific place. You cannot not put some chrono chat session ID. You just have to be there. Otherwise, it's not going to work.
Yes.
So and if something is not needed for it's optional, then put it somewhere else.
I guess at some point you have to enforce naming. You cannot let individual user using the same application to have its own or his own naming to figure out where the content is. Of course, that will take more time to find the content location. I think one last thing is that so there are like sub-communities within it who are applying NDN to vehicular networking. They're like taking as overlay network, for example. And then there are communities who are trying to get NDN towards IoTs. And then Edge, of course, is being nowadays very hot topic. So I don't think so that we need to have I will not use the term standard, but sort of an example naming scheme on the NDN website. Because if that thing that will be different for different applications, as we mentioned, that naming will be different for different applications. So if we want to see one naming scheme coming from the NDN website, then it has to be not only one, but it has to be for each different application. Let's say if you're applying for ITS, it should have a different naming scheme. If you're applying for disaster management, let's say it has a different thing. I'm nowadays working on device-to-device communication, and we are trying to find out some naming scheme which we are stuck into. I think it's more better to. I don't expect from NDN website to give me the naming scheme. What I do expect is to give me the preliminary knowledge that if I have to name a content for that sort of categorization of the application. So if I have to name a content in that sort of application, these should be the 1 or 2 thumb rules to do so. That's it. If they put the naming scheme on the website, then everybody will try to just stick to that naming scheme and do something else. So in that case, it will be hard for us to have more naming
Perhaps what we need is just guidelines at this point,
Exactly.
because even in one vertical, for instance, ITS, depending on the standard you use, European standard for naming ITS resources is different from US one, GTFS versus DATEX2, for instance. And so it's the application that drives, also because you are in a transportation system, so you have to drive. So this is the point. So guidelines, because if we start fixing categories, even in one category we have different application.
Yeah.
And so naming scheme should fit the requirements of the application.
Exactly. There can be high-level guidelines, and then everything like that. You can further take from that point.
Okay, so that's all the time we had. Let's thank the panelists.